The following are the 6 hyperbolic functions represented graphically. This is cos x, sec x, tan x, cos x, sin x, and cosec x. Hyperbolic functions, just like trigonometric ratios, they have identities. The relationship between hyperbolic identities and trigonometric identities is understood better through Osborne's rule. Let us do question number 6, part B. We are told to use Osborne's rule to derive identities for tan squared x and cos squared x from the corresponding trigonometric identities. Every hyperbolic function has got a corresponding trigonometric identity. In the trigonometric identity, we have signs which have been multiplied together or implied to be multiplied together. Then we have to change the sign to change that trigonometric identity to hyperbolic identity. And I want to give an example. There is this common trigonometric identity we use many times, that is sin squared x plus cos squared x is equal to 1. We can very easily turn it to hyperbolic identity using Osborne's rule. It states that the 6 trigonometric ratios used in trigonometric identities relating general angles may be replaced by their corresponding hyperbolic identity, but the sign of any direct or implied product of two signs must be changed. For example, in this case, we have got two signs multiplied together here. If now we want to convert this trigonometric identity to hyperbolic identity, the conversion becomes negative sin squared x plus cos squared x is equal to 1. So this is now hyperbolic identity, while this one is trigonometric identity. According to this equation, use Osborne's rule to derive the identity for tan squared x. Most of the trigonometric identities, we derive them from sin squared x plus cos squared x is equal to 1. So it is out of this we are going to get the trigonometric identity, which now we are going to use to convert to a hyperbolic identity. So let us divide this trigonometric identity by sin x. Therefore this becomes sin squared x plus cos squared x is equal to 1. We divide by here sin squared x. Here we divide by sin squared x over sin squared x, and here sin squared x and sin squared x will cancel. So what we have now is 1 plus cos squared x over sin squared x is cot squared x is equal to 1 over sin squared x is same as writing cosec squared x. This is one of the trigonometric identity that is going to help us to solve this one here, that is cos squared x. Let us now get the other trigonometric identity which we will use to convert to hyperbolic identity. Sin squared x plus cos squared x is equal to 1. I would like us now to divide this trigonometric identity by cos squared x. Here we divide by cos squared x, and here we divide by cos squared x. Cos squared x will cancel with cos squared x, and now sin squared x over cos squared x is written as tan squared x, and this one here is 1 and is equal to 1 over cos squared x is same as sec squared x. So that is the other trigonometric identity that we are going to use to convert to hyperbolic identity using Osborne's rule. So let us start with the second one, because this one is going to help us to solve Roman 1, and this one is going to help us to solve Roman 2. So we start with the Roman 1. In this trigonometric identity here, we have got two sine multiplied together. As you can see, sine squared x over cos squared x, you get tan squared x. So let us convert it to hyperbolic identity. So at this point we are going to change the sign. It becomes than squared x, and we have to change sign from positive to negative. Plus 1 is equal to sec squared x, and now you can see that than squared x therefore is equal to 1 minus sec squared x. We have proved the hyperbolic identity relating to than squared x. Let us now go to Roman 2, where we are proving, or rather where we are deriving the hyperbolic identity that relates to cos squared x. Now this one, as I had said earlier, we are going to get it from this trigonometric identity. Cot squared x plus 1 is equal to cosec squared x. We want to convert this trigonometric identity to hyperbolic identity using Osborne's rule, and in this case I want us to look at cot. In cot squared there is sine multiplied together, because cot squared is equal to cos squared over cos squared x over sine squared x, and in that case we have sine multiplied with another sine, and according to Osborne's rule we must change the sign when we are converting this trigonometric identity to hyperbolic identity. So the hyperbolic identity here now becomes negative cos squared x plus 1 is equal to cosec squared x. There is also a sign which is multiplied together, and therefore in this other case here, in this here and this cosec squared, we have to change the sign. Therefore we also are having a negative there. The hyperbolic identity relating to this trigonometric identity becomes cos squared x, that is negative, plus 1 is equal to negative cosec squared x. On rearranging this one, it becomes cos squared x is equal to cosec squared x plus 1, and we have proved the other hyperbolic identity.